I'm Shantala PT. I'm taking the subject microprocessor and computer organization, and this subject is a continuation from digital design and computer organization, where which you have studied in the last semester. Okay, so most of the concepts we have covered in the digital design, where we need for the microprocessor and computer organization, and we didn't discuss much about the computer organization, but whatever the required things we need, we are covering in the in this subject. Okay, so the subject is microprocessor and computer architecture. So what is a microprocessor here? Okay. Microprocessor, it is a device in a computer, okay, where it makes that which make things happen. Okay, without the microprocessor we are not able to anything in the computer. So microprocessors are capable of performing basic arithmetic operations, moving data from one place to other place, and making some decisions based on the quality of the certain values and quantity of the certain values. Okay. So without the microprocessor, nothing can be done in the computer system. So we are studying from the basic about the microprocessor as well as a computer architecture. So before that, we need to discuss here what is the difference between computer organization and computer architecture. Why we have a different subjects as computer organization and computer architecture. Sure, we'll discuss that also. Okay, and here in this subject we have anchor faculty, Dr. Kiran sir, and he is in our campus only. He takes for the sections EFG, and we have an anchor video. So I want to put the introduction video, and here Riga sir has explained regarding the subject about ESA ISA, how we are going to split, whether we have a assignment component or we have a quizzes, and how many quizzes and how the marks are going to split in the quiz. Okay, and just I'll put the video, go through the video. If you have any doubts regarding the assignment components or quiz components, so immediately you can clear the doubts. So because then you can take the decision how you can attend the quizzes as well as the test. Anyway, ESA ISA is compulsory, that is a part of your marks, and the quiz component is little bit different here, and we are not providing any additional quiz, okay, apart what we are discussing in the video. Okay, so let me put the video, and sir is also going to explain the all the what we are going to cover in all the units, and as well as the marks distribution, and as well as the course information. So this will be the introduction video for the microprocessor and computer organization, and all the first three videos are uploaded in the PESO Academy, and four PPTs are uploaded in the PESO Academy, as well as the material of the first unit is also uploaded in the PESO Academy. So after each classes, and at the end of the week, so I'm suggesting you to watch all the videos, so you will recall all the what are the things happen in that particular week. Okay, that will help you a lot. Okay, so I'll share the video.
Hello.
So this will be your introduction video of the subject.
everyone. Happy New Year and greetings for the day. This is Dr. Kiran, Faculty, Computer Science Department, PS University. Welcome to the first session of the course Microprocessor and Computer Architecture, in short, MUPCA. MUPCA is a core course under the curriculum and an important course for any computer science engineer. MUPCA is a continuation of the Digital Design and Computer Organization course which we studied in the last semester. However, we are not going to look into the hardware in depth, but we are going to look at the hardware in the programmer's perspective. First, we look at the syllabus, the book, and the evaluation pattern which is followed in the course. Then we'll have an overview of the course. Coming to digital design, what is that we have studied in the digital design course? In the digital design course, we learn how to build the logical circuit, keeping speed, time, and space in mind. We studied multiple optimization techniques so that we design a circuit which is fast, space, and energy efficient. Coming to computer organization, under computer organization, we realize that there is a hardware abstraction above the digital logic and below the operating system. Hardware units were made transparent to the programmer so that he can write the program keeping hardware in mind. Hardware units such as data path of the processor, control signals, interfaces, and memory technologies which are used and how they are interconnected logically also we studied. Next, we are going to understand the microprocessor here. Microprocessor are nothing but basic computing unit on the integrated chip. It's the brain of the computer which will compute whatever user want and produce the result. Coming to computer architecture is slightly different from the computer organization. Here we discuss about lot of engineering decisions and the trade-off in designing a good uh, system, computer system, keeping again time, space, and resource in. What we need to realize in today's class is that the difference between the computer organization and the computer architecture. The statement tells that manufacturer offers family of computer models with same architecture but different organization. Computer organization is realization of the computer architecture. Computer architecture survive for long time, but there will be frequent change in the computer organization. For example, if the computer architecture specify that there should be a multiplication operation at the organization level, we can decide whether to go for a multiplier circuit, which we realized is a costly operation, or to go for an add operation which can be used multiple times to perform the multiplication. So this decision is taken at the organization level, but what operation should be involved in the design of the system is discussed at the architecture level, right? All the trade-off and the decisions are discussed at the architecture level. Coming to the syllabus, in the beginning, in the unit 1, we'll be studying different basic processor design. Especially we'll be looking at the ARM processors. And the second unit will look at the advanced level of processor design using the pipelining. In the third unit, we'll realize that memory is also an important unit in the program execution. It plays an important role in the program execution. So we'll discuss the memory design. In the fourth unit, we'll look at the input and output device design. Again, we'll understand that the input output device will play a major role in the program execution. In the unit 5, we'll look at the different advanced architectures in any new development which have happened in the recent past, which include multi-core processors, so that we'll realize how a multi-core processor can be programmed. Coming to the textbook, we have two textbooks and two reference books. The first textbook, Computer Organization and Design by Hansi Patterson. The textbook 2, ARM System on Chip Architecture by Steve Farber. These two textbooks are important for us in order to understand the concept whatever we are studying in the class. Also, the reference 1, Computer Architecture, a quantity approach, which is also an important book for us so that we can explore more concepts. We can go more depth for a certain concept which are not available in the textbook 1. Reference 2 talks about the ARM processor, which may help us in our lab sessions as well. Coming to an important slide, which is nothing but the evaluation of the course. We have 4 components: ISA 1, ISA 2, quiz and ESA. ISA 1 is for 24%, ISA 2 16%, quiz 10%, ESA 50%. ISA 1, ISA 2 and ESA are straightforward offline exams. Quiz may be the online quizzes, which is administered in a different way, which is written here. We'll be conducting 5 quizzes for total 10%. That means that each quiz should be 2.5%. However, we are going to conduct each quiz for 4% instead of 2.5%. Student is expected to score a total of 10% out of this 5 quiz, which is conducted for 20%. That means to say that if a student attend 2.5 quiz, he should be able to make 10%. Another 2.5 quiz is extra for gaining the knowledge or to compensate the marks which he or she has lost in the previous quiz. So if you attend all the 5 quiz and if you score full marks also, though you achieve 20%, it will be scaled down to 10%. There is a cap of 10%. So this is with respect to the evaluation component. Next, coming to team of faculty members. marks also, though you if a student attend ESA 50%. ISA 1, ISA 2 and ESA are straightforward offline exams. Quiz maybe the online quizzes, which is administered in a different way, which is written here.
Hello.
We'll be conducting 5 quizzes for.
Hello. And students, are you clear with the quizzes and the ISA, ESA component? Hello. Have you any
Yes, ma'am.
doubts with the ISA component in that quiz component?
Ma'am, I didn't understand the quiz component part.
Yeah. That's why. Just let me explain first. Then you, it is easy to decide here. Take a decision.
Unit on the integrated chip. It's the brain of the computer, which will compute
So are you
whatever
able to see
user
anything?
want
No,
and
no.
produce the result.
Hello. It is
No, ma'am.
coming black. No. Okay. Gee, videos.
Hello everyone.
See here. See if we conduct ISA 1 3 units and ISA 2 2 units, okay, as in the DDCO, but in the DDCO we were not having any of the assignments, okay, so directly we reduced to
They
30
are
marks and 20 marks
interconnected
here.
logically. Also, we studied. This is Dr. Kiran.
And but here this time instead of reducing 30 marks, okay, so you will get 24 marks, okay, 24 marks in the ISA 1 and 16 marks in the ISA 2. We are reducing, so 16 marks instead of 20 for the ISA 2. Okay. So then you will be having how much? 40 marks. Extra 10 marks we are conducting for quiz. Okay. Is it okay now? Okay. So the 10 marks how you are going to earn, that we need to discuss. Okay. Let me go to the PPTs. Okay, so you can see here, see we are conducting 10 marks quiz, 4 regular quizzes, each 4%. I mean we are conducting for 10 marks. One quiz is 10 marks and we are reducing to 4 marks. Okay, so finally you are going to get 10 marks. Okay, and 4 regular quiz we are conducting. One quiz is a improvement quiz. Out of 4 regular quizzes, we are we are covering all the units. You can see here unit 1 is for first quiz, unit 2 second quiz, unit 3 and 4 third quiz, unit 4 and 5 is a fifth quiz, and one improvement quiz for 4 marks which covers all the units. So how the marks are going to split here? See the example, student should score minimum of 10%, maximum of 10% in cumulative fashion from all the 5 quizzes. Suppose if you attend first quiz, assume you got full 10 marks. So we are reducing to 4 marks. So you have 4 marks in the pocket. Okay. And if you attend second quiz, if you get full marks, another 4 marks is added, you will get 8 marks. Okay. So then one minimum 3 quiz you have to attend to get full 10 marks. Minimum 3 quiz. It's not like that even if you are conducting 5 quizzes, it's not compulsory to attend all the quizzes. We are giving more and more option to get full 10 marks for you. Okay, but minimum 2.5 quiz. I mean 3 quiz you have to attend. From 2 quizzes, if you get 4 plus 4, 8. From the third quiz, if you get only the 50%, so you have full 10 marks. Okay, so minimum 2.5, I mean 3 quizzes you have to attend. So see the example 1, 2%, 2%, 2%, 2% and one more 2%. I mean from if you attend all the 5 quizzes with 2 marks, I mean 50 percentage, you will get the 10 marks. Okay, and in the first quiz if you get 3 marks, second quiz 3 marks, third quiz 3 marks, and you have to attend the 4 marks to get one more mark, then it's a 10%. Okay, and again see one more option, 2 plus 3 plus 2 plus 4 which is equal to 11, but we are going to deduct 1 marks, we will give 10 marks only. If it is 4 plus 4 plus 4, we are deducting 2. Suppose if you want to learn all the concept for the quiz, if you want to attend all the quiz component, you will get 20 marks. So then also we are giving 10 marks only. So extra makeup quiz will not be conducted here if the student miss any quiz component, because we have giving maximum chance here itself. So I hope it is clear now, isn't it? Yes, students?
Yes, ma'am.
So here because we are giving more chance. Okay. So if you attend first 3 quiz itself, enough. So you'll be having quiz component is 10 marks. So other component is from the ISA. I hope all of you got the ESA and ISA component for the theory. Yes?
Yes, ma'am.
Sorry, I think network is slow. It seems it is taking time.
This is Dr. Kiran, Faculty, Computer Science Department, PS University. Welcome to the first session of the course Microprocessor and Computer Architecture. In short, MUPCA. Concepts, we can go more depth for a certain concept which are not available in the textbook. 1. Reference 2 talks about the ARM processor, which may help us in our lab sessions as well. Coming to an important slide, which is nothing but the evaluation of the course. We have 4 components: ISA 1, ISA 2, quiz and ESA. ISA 1 is for 25. The team includes Professor Badri Prasad, Professor Rupa Ravish, and Professor Supriya Madam. So you can communicate with us for discussing anything which are related to the course. Understand multiple times. Understand the concept whatever we are studying in the class. Also, the reference one come to architecture, a quantity approach, which is also an important book for us so that we can explore more concepts. We can go more depth for a certain concept which are not available in the textbook one. Reference 2 talks about the ARM processor, which may help us in our 5. That means to say that 10 hardware course. If it is a hardware course, I want to write only program. Why should I learn the course? I'm a computer science engineer. I love to write program. Why should I learn this course? Is the question. Normally, everybody will have before starting the course. But believe me, this course is important for any computer science engineer so that he can write an efficient program. What are the programming requirements? If I write a program, that program should be correct. If I write a program, that program should execute fast. If I write a program, it should consume less power. If I write a program, it should utilize less memory, or the memory access should be fast. If I write a program, it should communicate less with others, or it should communicate fast so that it can execute fast and completes its execution. Normally, we are bothered about first 2 points, correctness and the speed. But later on, we'll realize that power, memory utilization and communication also is very much important. If you don't understand the hardware, if you don't understand the architecture, other 3 points cannot be used for writing the program. What is that we do? We write, being a programmer, developer, or the analyst, we write the program without knowing the computer architecture or organization. Like we drive the car without knowing what is there inside the car, what are the technical things which are related to the car. We write the high level program without understanding how the program execute or the environment in which the program is going to execute. We use different packages without knowing how they are implemented and how they are going to act in the environment in which it is going to work. What we need to understand is that along with writing a program which will execute fast and efficient, whether it is keeping my CPU busy, whether my CPU is busy in executing my program fast, is one thing which we need to realize. Second thing, always are we are okay with the program which will do what we want. We never bother about those things which my program should not do it, which I am not intending to. Like, for example, I have a expression here, 2 plus 3 into 4. It should not give me answer as 20 instead of 14. First, it should multiply 3 into 4. Then it should add with 2. That is what I intend. But if it perform addition first and multiply, then it's a wrong operation. So very simple thing. This lot of things can be of this type. If you don't understand the hardware or if you don't understand the system side, we assume that my program is executing or performing the action as I intend, but sometime your program may act the other way around, which may execute in a way which you don't want it to execute. In order to realize those type of thing, you need to understand the MuPCA concepts. So for your reference, I have taken few bytes from the software professionals. You can go through it. 3 bytes. First byte tells that by understanding the data structure, necessarily the storage, if you don't realize the what is there inside the data structure, how it is designed, how it is implemented, you cannot write the efficient program. Similarly, if you don't understand how a compiler translate your program for a particular architecture, again you will not be able to write an efficient program. Similarly, if you don't understand the environment, the architecture background at which your program is going to execute, you will not be able to write an efficient program. Although at the algorithm level, your program may be algorithmically you may prove it is efficient, but when it go for execution, if it is not designed keeping the hardware in mind, your program will not execute efficiently. Who is responsible for making your program to execute efficiently? You can see here we have a stick man who has written a beautiful program, hello world, and is going to give it to the computer. Computer, it don't understand the high level program. When it don't understand the high level program, whatever program you write, whatever beautiful program you write, it thinks that the stick man is a bored guy. How to bridge the gap between the user and the hardware? Who is responsible? Who are all the players we have? We have the programmer. The programmer alone is responsible for making the program uh, to make it understand by the computer, or do we need help of the operating system? Do we need help of the compiler or the interpreter? We used compiler. This is the compiler you used in your data structure course and C programming course, which convert your high level program to uh, executable code. right? So whether compiler is responsible for writing an efficient or converting your code to an efficient code, or the hardware is whole and sole responsible for executing your.
Students, this particular slide shows what is actually happening inside the computer. Okay. So for example, in the lab, if you go to the lab, you will write one C programming or any high level language programming. Just and you will use some compiling codes to run the program, and you will get the output also in high level language. But as you know, computer can understand only the machine level language, that is in the form of zeros and ones. Okay, so inside from the next step, I mean starting from the high level language and to get back the result in the high level language, so what are the things going inside the computer? Actually, we are not bothering about that. Simply we will work with the program, we'll get the output and will come out from the lab. But we need to know, as a computer engineers, you need to know how the program is going to executing and what are the softwares are running inside the computer. Either the software are system software or it can be application software. To use one application software, you are using many of the system software. Either it can be operating system. Sure, operating system is one which you need to enter the program to the computer, and it is actually communication channel like that. Without the operating system, you cannot communicate with the computer. And if you use the high level language, obviously you are not writing the machine level language, but you should know what is a machine level language and how the high level language is going to convert to the machine level language, and what are the different steps we have in the conversion from high level language to machine level language, and which of the compilers, either it is an interpreter, and what are the hardware parts we have to communicate with the computer. Either it can be a processor, so why we require a processor, or it can be a memory, so why we need the memory usually need to store your program, then the processor works with the program, and what are the different IO devices, etc. So here this sir is explaining how the things are going to happen from the main program, between programmer and the computer.
Your program, whether it is processor, memory, or IO. This is what we are going to realize, right? So now my computer is thinking that Stickman is a bore guy. So how to make my computer to understand what the Stickman has written? So we have a compiler which will convert the high level program to low level program, specifically the assembly code, which is created keeping the hardware in mind. I know what type of instruction my computer understand, and this instruction, keeping those instruction, my compiler will convert that code to target code, or the code which is understandable by the computer. Is this enough? The code whatever I've written, is it enough for me to execute on a single environment? No, there can be multiple environment which your code need to be executed. So it is my responsibility of the compiler to convert this user code to a code which will be understood by different architecture, by understanding the hardware or the instruction which belong to different architecture. So I need to make all the architecture to understand. And also we need to keep in mind that we need to compile the code such that the target code is efficient in all the hardware. Next question is that my computer asks is that I understand the code because you have compiled it now, but it's too big for me to store it in my memory. So now who comes into picture for help? Now comes the operating system to answer this. Operating system will help your program to be stored safely efficiently on the hardware memory so that whenever my CPU asks for the code, it will take that code and it will give it for execution. What next? I stored your program, but I need space for other programs also. I'm going to store the program of multiple users and sometimes the system program also. I need space. Where should I keep your program? Can I keep in between the other programs? If I do that, how are you going to recognize your program? How are you going to fetch the program? So I need operating system help for it. So address, finding the, storing the program in the hardware and knowing the address from where it should be fetched also is important, which is the responsibility of the operating system. Now, I have stored your program, but when your processor is executing, how do I know what your program needs? What instruction I should give it to your CPU? So, a lot of addressing mode I need to understand so that I can fetch the required data and the instruction from the memory and I will give it to my processor for execution. Also, I need to answer who is my master, the system software or the user. Many times it happens that many programs will be competing to execute, sometimes few user programs, sometimes system programs itself. So who will be given chance to execute? Why they should be given chance? Whether there is a priority given to different program for execution need to be answered. Based on the decision, they should be sent for execution. When they are sent for execution, what will happen to the current program in execution? A lot of things are there which we need to answer, which we need to understand. So operating system will answer all these type of question. So we need to understand what are the responsibility of the operating system also. So I understood the compiler, I understood the operating system. Now coming to the processor itself. Now I have a program here which will add two instruction, a equal to a plus b, c equal to a minus b. When I convert that program into low level program, I have two instruction, add or not r1, subtract r2 or not r1. So how I'm going to execute this program? So in the sequential execution, I'll execute them one by one. Is that sufficient? Is that efficient way of doing it? The next question is that if I execute them together, will I complete soon? Whether I'll be able to complete my operation soon. There comes the concept of the pipeline processor, multiprocessors, multi-core processors, which can execute more than one program, more than one instruction at a time. These are all the things which we need to understand. Also, there is a misconception that many times the processor will be happily spending time in doing the arithmetic operation like this. Every time it will have the program, every time it will have the data to perform the operation. But this is the misconception. Many times my processor will be like this, waiting for the instruction and waiting for the data. You will realize in the next slide here, this is the data which is collected when and few test benches were executed to test how much time the uh, processor spent in doing what type of operation. The survey tells that 43% of the time the processor spent time in data movement, 23% of the time spent on control flow, 15% of the data time spent on the arithmetic operation. That means the computation, what I was thinking, I'm doing it only for 15%. Most of the time I'm spending communicating with the memory, which will be of no usage for the fast execution. It will slow down my execution time. For example, you can see at the left, simple add operation I want to add, which is in the red color, R6, R4, R5. R4, R5 I want to add and I want to store it in R6. First I need to load the value of A into R0. Then I need to load B to R1. I need to extract the data which is in the R0 and R1. I need to store that in R4 and R5. Then I need to add that data R4, R5, and I need to store the result in R6, and I need to store that R6 back into the location specified by the register R3. That is the meaning of that. You can see there, except the add instruction, other instructions are load and store. These are all the data movement instruction which will be referred to the memory for loading and storing the data for doing the computation. So 43% of the time I spent on data movement itself, right? So question is, I need my CPU is idle, right? You can relate that with my previous slide. So my CPU is idle most of the time because a lot of data movement operations will be happening. I'll be having very less data to execute. Right. So how to overcome this? How to keep my CPU busy? I don't want to keep my CPU idle. Right. So the goal of the course is to apply all engineering techniques to ensure that my program execute fast by making sure that my CPU will not be idle. Right. So the quote is that if I know what time is spent for what operation, I can work on it to ensure that the processor will work faster. So the goal of the course is to ensure that I keep my CPU busy. Always I quote in my class that the highest crime what a computer science engineer can do in his life is that keeping CPU idle. If you keep your CPU idle, that is the, if your program is making your CPU idle, that this is the ultimate crime what you can make in a computer science profession. So whether you are building the OS, whether you are building the compiler, whether you are building the hardware, whether you are writing program without knowing how the OS work, how the compiler work, how the hardware look like, then there is always chance that your program will keep your CPU idle because no optimizations will be done based on the architecture. So what we learn here in this course, again coming back to your syllabus at the architecture in the first unit, uh, we learn different design issues, instruction sets, and addressing modes, keeping ARM processor, which is a RISC processor, in mind. We'll understand the difference between the RISC and CISC in the first unit. In the second unit, we'll try to understand the advanced concept, how to ensure that more than one instruction can be executed. So that is called the pipeline. And we'll evaluate the performance of the pipeline processor and the non-pipelined processors. In the unit 3, we design the memory in order to ensure that upon the optimizations. Then we'll work on the input output devices. Again, we'll see how performance can be improved. Understand what are the modern.
Yes, students, this is actually the introduction class. What is the computer organization and computer architecture? And these are all the course outcome. So in each unit, what are the things we are going to study? Okay. So from tomorrow's class, we are going to start with the unit 1 basic processor architecture and the design. Okay. Goodbye, students.